Have you ever looked up at the night sky and wondered what's out there, beyond the stars we can see? We know about planets, stars, and galaxies, but scientists believe that all of this makes up only 5% of the entire universe. The other 95%? Well, that's the great cosmic mystery. About 27% of it is something called dark matter. It's invisible, it doesn't emit light or energy, but we know it is there because of its gravitational pull on the things we can see. It's the hidden cosmic web holding galaxies together, but what if it's more than just invisible matter? What if dark matter is trying to talk to us? This might sound like science fiction, but it's a question that some physicists are actually starting to explore. The idea isn't that there are little aliens made of dark matter sending radio signals. The communication would be far more subtle and bizarre, operating on principles of physics we're just beginning to understand. To get our heads around this, we first need to appreciate just how strange dark matter is. For decades, the leading theory was that dark matter consists of WIMPs, weakly interacting massive particles. These are hypothetical particles that are heavy and don't interact much with normal matter, which is why we can't see them. We've built massive, incredibly sensitive detectors deep underground, shielded from cosmic rays, all in an attempt to catch a single WIMP bouncing off an atom. But after years of searching, we found nothing, not a single confirmed detection. This lack of evidence has pushed physicists to think outside the box. Maybe dark matter isn't made of simple solitary particles. Maybe it belongs to a dark sector, a whole hidden universe of particles and forces that mirrors our own. Imagine a world existing all around us, in the same space but made of stuff that is almost completely invisible to us. In this dark sector, there could be dark electrons, dark photons, even dark chemistry, leading to complex structures, maybe even dark life. If our universe has atoms that can combine to form stars, planets, and people, why couldn't the dark sector have its own version of complexity? It's a mind-bending thought. We could be walking through a dark galaxy right now and not even know it. So, if this complex dark sector exists, how could it possibly communicate with our world? The key is what physicists call portals. These aren't physical doors, but rather hypothetical particles or forces that could act as a bridge between our visible sector and the dark sector. One of the most popular candidates for such a portal is the dark photon. Just as our photons carry the electromagnetic force, allowing us to see and interact with the world, dark photons would carry a force within the dark sector. Crucially, some theories suggest that dark photons could mix ever so slightly with our regular photons. This mixing would be incredibly weak, but it would provide a tiny window between our two worlds. Think of it like two separate Wi-Fi networks in the same house. Usually they don't interact. But if they were set to a very similar frequency, they might occasionally interfere with each other, causing a flicker of static. In the same way, a dark photon could, on rare occasions, transform into a regular photon that our instruments could detect. If there were complex processes happening in a dark sector, let's say, something analogous to a dark star emitting dark light, this process could generate a faint, specific signal in our world. This wouldn't be a message like, "Hello, world," but a predictable pattern of photons, perhaps at a very specific energy or frequency, that couldn't be explained by any known astronomical process. Physicist and author of the book The Dark Side of the Universe, Dr. James Basham, is one of the researchers exploring these very ideas. He and his colleagues propose experiments that don't just look for a single bump of a particle, but instead search for more complex signals. For example, could we build a detector that acts like a dark radio, tuned to listen for these potential dark photon signals? These experiments would scan for unusual photon emissions coming from areas dense with dark matter, like the center of our galaxy. If we detected a signal that was coherent or had a complex structure like a pulse or a wave, it would be a revolutionary discovery. It would suggest that the dark sector isn't just a simple inert substance, but has dynamics and structure. Now, let's take this one step further. If the dark sector is complex enough to have its own forces and particles, could it be complex enough for information? A key element of communication is the ability to encode information. We do it with sound waves, light waves, and electrical signals. If dark matter can form structures, maybe those structures can store or transmit information. A team of physicists, including Gia Dvali, has proposed a fascinating theory. They suggest that some types of dark matter could behave like a quantum computer. Specifically, they looked at a type of hypothetical particle called an axion. They theorized that in the powerful gravitational fields of black holes, axions could form a Bose-Einstein condensate, a strange state of matter where millions of particles act as a single quantum entity. This axion cloud around a black hole could, in theory, store and process vast amounts of information, much like a hard drive. What's more, through a process called superradiance, this system could release that information in the form of gravitational waves or photons. So, what kind of message would it be sending? It wouldn't be a greeting. Instead, it might be broadcasting the fundamental laws of its own complex physics. By carefully analyzing the signals coming from black holes, we might be able to decode these messages and learn about the nature of the dark sector. It's like finding an alien artifact that, instead of saying, "We come in peace," contains an encyclopedia of their science. Of course, we have to be extremely careful here. When we talk about communication or information, we're not necessarily implying intelligence or intention. A pulsar, which is a rapidly spinning neutron star, sends out incredibly regular radio pulses. It's communicating a message its rotation speed, but it's not intelligent. It's just a natural physical process. Any signal we might detect from the dark sector would likely be of this nature, a natural consequence of its physics, not a deliberate message from a dark civilization. But even that would be one of the greatest discoveries in human history. It would prove that the universe is far richer and more complex than we ever imagined. The search for these signals is already beginning. Experiments like the Large Hadron Collider, while famous for discovering the Higgs boson, are also looking for signs of dark photons and other portal particles. Radio telescopes are scanning the skies for unusual signals that don't fit our current models. Gravitational wave observatories like LIGO are listening for the echoes of cosmic events, which might include whispers from the dark sector. Each new piece of data is another page in our cosmic detective story. We're looking for a needle in a haystack, but a needle that could rewrite our understanding of reality. So, could dark matter be communicating with us? The honest answer is, it's a long shot, but it's not impossible. The universe has surprised us time and time again. A century ago, the idea of black holes or gravitational waves was pure theory. Today, we can take pictures of them and measure their ripples in spacetime. The quest to understand dark matter is pushing us to be more creative and to imagine possibilities that blur the line between known physics and science fiction. Whether dark matter is just a simple silent particle or part of a rich, dynamic hidden world, the search for an answer is one of the most exciting journeys in all of science. It reminds us that even when we feel like we know a lot, the vast majority of the universe is still a complete and utter mystery waiting to be explored. Thanks for joining me on this journey into the cosmic unknown. If you enjoyed this exploration of the mysteries of dark matter, please hit that like button and subscribe for more deep dives into science and the universe. And let me know in the comments, what do you think dark matter is? I'd love to hear your theories. Until next time, keep looking up.